A positive integer that is the same when read forwards or backwards is called a palindrome. The table is created as shown, in which the first column contains all palindromes between 1,000 and 10,000, listed in increasing order. The second column contains the positive differences between each pair of consecutive palindromes. For example, 1001 and 1111 are consecutive palindromes, and their positive difference is 110. What are the 8th and 9th palindromes in the first column of the table? Let's create the table. So we have the palindromes and we have the positive difference. So there we go. And shouldn't be, what do they want? The 8th and 9th, right? Okay, so we don't have to do too much here. So 1, 2, 3, 4, 5, 6, 7, 8. 8th and 9th. Okay, so we got 1, 0, 0, 1, 1, 1, 1, 1, 1, 2, 2, 1, and so on, right? It's not that difficult to come up with these. And then let's list them all. Well, not all, but just until we get to the 8th and 9th. And the 9th would be 1, 8, 8, 1. Okay, so we've got the 8th and 9th, and then we need the positive difference. So the positive difference here is 110. And I believe they're all 110, but maybe not every single one. Let's see here. So far, they're all 110. 110, hold on. And then this one is also 110. And I believe this one is 110. Okay, so far, we're just sitting at 110. Okay, so that takes care of part A. Part B, in the second column of the table contains only two different numbers, 110 and x. Okay. So that's pretty much what I was thinking of, that are they all 110? And this part B basically is saying that there's going to be two differences, 110 and something else, and they want you to figure out that something else. Well, to figure that out, you just have to keep extrapolating here, just keep coming up with differences. Well, so far I keep getting 110. Let's see, the 11th one, what would be the 11th palindrome here? That would be 2002, I think. So that one would give me 9 plus 2, 11. Okay. So as you can see, these are all 110, and there's 9 of them. But then eventually you get like an 11, and then it goes right back to being 110 again. So the value of x is 11. And then as you can probably see, if I go to 12, it's 2112, and that would be 110. So it goes right back to being 110 again for another 9. When the table is complete, there are n palindromes in the first column. What is the value of n? Okay, so the table is going from 1,000 to 10,000, right? Okay, so obviously I'm not going to draw them all out. So we're going to have to figure out a system here of trying to come up with the number n. Okay, that system should not be that hard. Let's see if I can figure this out. From 1,000 to 1,999, that actually I kind of have here. We got 10 palindromes. And I think that's pretty much going to be the story for every range of 1,000. So from 2,000 to 2,999, it's going to be 10, and so on down. From 9,000 all the way to 9,999, there's going to be 10. So there's 9 groups of thousands, right? This is the first, this is the second, this is the 9th. And for each of those 9, there's 10 palindromes, so a total of 90. 90 is the answer. Okay, finally, determine the average of all of the n-1 numbers in the second column of the table. So when they say second column of the table, there's this one. So there's n-1. Okay, that makes sense, right? Because think about it. If you just look at these 10, right, from 1 to 10, there was 10 palindromes, but there's 9 differences, right? So that's why if there's n palindromes, there'll be n-1 differences. And that's why there's n-1 in that second column. All right, that shouldn't be that big of a deal. Let's see if I can create a system here. Again, obviously I'm not going to write them all out. I have to create a system. Okay, so there's 90 palindromes. That's what we kind of concluded from the previous question. So that means there's 89 differences, 89 positive differences. Okay, so that's the first part. And then what? And then there's this 9-to-1 ratio, right? There's 9 1/10s, and then there's 1 11, and then it kind of just repeats like that. Yeah. Okay. Yeah, I'm pretty sure that's the pattern. So if you just look at it from the perspective of like the first 1,000, 1,000 to 199, there's 9 of those guys that are 110 differences, and then there would be, hold on. Yeah, 9. Yeah. And then similarly for 2,000 to 2,999, again, there'd be 9 positive differences that are 110. So if you keep extrapolating, there's going to be 9 of these groups, right, all the way down to 9,000 to 9,999. And each has 9 110s. So 9 times 9. So there's 81 110s. Does that make sense? Well, there's 89 total positive differences. So that means the remaining, which is 89 minus 81, which is 8, those 8 would be 11s. They would be these guys. Okay, so that means we can figure out the average pretty easily. It'd be 81 times 110. That would take care of these guys. Plus 8 times 11. That would be those guys. And then divide by the total, which is 89. And that's going to be 8998 over 89. In the diagram, the circle shown has center 6, 8. Has radius 10, and the equation x minus 6 squared plus y minus 8 squared is 100. And the circle passes through the origin. Determine the coordinates of P where the circle intersects the x-axis. Circle intersects the x-axis, obviously, when y is 0. So all you really have to do is take that equation and put y equals 0. So it would be x minus 6 squared plus 0 minus 8 squared is equal to 100. So that would be x minus 6 squared is 100 minus 8 squared is 64. So 100 minus 64. So x minus 6 squared is 36, and therefore x minus 6 would be plus or minus 6. And when you solve for that, you'll get x equal to either 0 or 12. So that's the 0 one, and then therefore this is the 12 one. P0 would be the coordinates. Part B, determine without justification the coordinates of the point Q on the circle that has the maximum y-coordinate among all the points. All right. Maximum y-coordinate, huh? Okay, so I think that would be right up here, all the way up at the top. So obviously we're talking about this point right there. And they're calling it Q. So Q and the coordinates. Now, since it's exactly going north from 6, 8, I assume that the x-coordinate would be the same. The x-coordinate would be 6. Yeah. And the radius, did they tell us? The radius is 10, so it's going from the center all the way to the top, which is 10. So it would go from 8 to exactly adding 10 to that. So that would be 8 plus 10, which is 18. So I guess just by looking at the diagram, we can figure out the coordinates of Q. Part C, determine the coordinates of R so that PQR is 90. PQR is 90. Okay. PQR is 90. All right, so let me attempt here to draw where R might be. PQR. That's where I think, because if PQR is 90, right, that basically means that it is inside a semicircle. Let me explain. Some of you already know that, but I'll just try to draw these lines in first and then explain it. Okay, so there we go. There's PQR, right? So if PQR, I got to draw an R. If that is indeed 90 degrees, then that means that PR is the diameter. And that's the only way that PQR will be 90 degrees. And that's just a property of an angle drawn within a semicircle. Okay, so what are we asking for? Oh, the coordinates of R. All right. Well, I think you probably just use the midpoint formula, right? Because C is the midpoint of PR, since P and R are both on the circle, and they're the diameter, and PR is the diameter, and C is the center. So C is the midpoint of PR, so I guess we just use the midpoint formula. I'll just call this AB since I don't know the coordinates. And I actually am not 100% sure if it's going to be on the y-axis. It certainly looks that way, but let's just see. So let's see here. That would be A plus 12 divided by 2 is equal to 6. And that would mean that A is 0. Okay, that's it is on the y-axis. And then now let's figure out B would be B plus 0 divided by 2 is 8. So that means B is equal to 16. So there we go. 0 and 16 are the coordinates of R. Determine the coordinates of the two distinct points S and T on the circle so that the angle PQS and PQT are 45. So this is going to require a diagram. And this is a diagram that illustrates what we need to do in order to solve this question. So we've got P and Q and S, and they are going to make a 45-degree angle. So first I've got to put in the other letters. So Q is all the way at the top, right? So this is Q all the way at the top right there. So we've got to label that Q right there. And then S and T, S will be here and T will be here. So that those angles PQS, let me draw that in. So P to Q and then Q to S, right? That's going to be a 45-degree angle. And then, of course, the other one is the PQT. So P, Q, and then T. There we go, like that. All right, so how do we approach this? Well, you really have to look at it from the perspective that you're looking at really C and P. And with similar triangles, you can deduce that when you go down from C to P, in the same kind of way you go from C to S and C to T. So let me explain. When you go from C, which is 6, 8, you're going to go to get to, let's see here, to get to P, P was what in terms of coordinates? I believe it was 12, 0, right? Yeah, 12, 0. Yeah. So to get from C to P, we basically had to go down, let's think about this. We had to go down 6, and that's why we see this 6 here, right here. That's how much you had to go down. And then to go from 8 to 0, we had to go across 6. Sorry about that. I wrote this is the 6 that I'm talking about. To go from 6 to 12, we had to go to the right by 6, and that's why this is 6 from here to here. And then to go from 8 to 0, we had to go down by 8, and that's why we have this 8 here. All right, so now that finally we got that straightened out. With similar triangles, you can figure out that to go from C to S, it's going to be also an 8 and 6, and then to go from C to T, it's also going to be a 6 and 8. And similar triangles exist because, for example, if this is theta, this would be 90 minus theta, and then therefore this angle in here would be theta right here. And then therefore this angle would be 90 minus theta, this one in here, 90 minus theta. So they're all similar triangles since this angle is 90 minus theta. 90 minus theta. So that's why you can be sure that the distances are the same. And the diameter is from S to T, because remember the question even tells you that PQS is 45 and PQT is 45, so that total is 90, and that ensures that ST is the diameter. ST is diameter. And since ST is the diameter, SC is a radius, which is 10. We know that from a previous question. And then we also know that CT would be 10, since that's the radius, and CP is 10. So SC is equal to CT is equal to CP, which is all equal to 10. All right. So now we got to figure out the coordinates of S and T, I believe. So to go from C, which is 6, 8, to S, we would have to go, let me get this right this time. We'd have to go right 8, because I'm looking at this guy now. So I've got to go right 8. So I've got to add 8 to that guy. So I've got to go right 8. So that's going to be 14. And then I've got to go up 6. So up 6. And that would mean I'd add 8 to, I'd add 6 to that 8, and that would be 14. So that's the coordinates of S. Okay, so in a very similar way, we're going to go now to T. From 6 to 6, 8, to get to T, we have to go down 6. So down 6. So that's actually the y coordinate. So that would mean 8 minus 6. So that would make this 2. And then we'd have to go left by 8. So 6. So left 8. So 6 minus 8, which is minus 2. So there we go. We got the coordinates for S and T. For each positive integer n, define an and bn to be the positive integers such that root 3 plus root 2 to the 2n is an plus bn root 6, and root 3 minus root 2 to the 2n is an minus bn root 6. Determine the values of a2 and b2. So for the first two, a2 and b2, I guess all we're really doing is setting n equal to 2. Therefore, a2 would be root 3 plus root 2 to the 4. And that's a2 plus b2 root 6. And then b2, that would be root 3 minus root 2 to the 4 is a2 minus b2 root 6. What I mean is that's the two equations, and then you'd have to solve them. If I add these two equations, I'll get 2a2, the root, these b2's disappear, and then this actually is 98. I'll let you guys do that. You can crunch out those numbers in a calculator, and therefore a2 would be 49. And then if you sub that back into either one of these, you can calculate that b2 is 20. Okay, so that takes care of a2 and b2. And part B, prove that 2a 2n minus 1 is less than root 3 plus root 2 to the 2n is less than 2an for all positive integers n. So let's see here. What are we trying to prove here? 2an minus 1 is less than root 3 plus root 2 to the 2n less than 2an. Okay. All right, so where do we start here? I guess the only place to start is just the two equations that they gave us. That's all I have, actually. So if I add them like I did previously, I will actually have that 2an would be equal to root 3 plus root 2 to the 2n plus root 3 minus root 2 to the 2n. Correct? Just by adding those two, because the b stuff disappears. All right. Okay, these guys, I'm going to write on the side what they are like in terms of their decimal. Root 3 plus root 2, I think is about 3.1, I think. And then root, because it's 1.4 and 1.7, right? So 1.4 minus 1.7 would be about 0.3. Okay, so the reason I did that is I just wanted to get a ballpark estimate. So that basically means that just root 3 minus root 2 it's 0.3, so it's between 1 and 0. I'm just trying to see how to do this, because I've got a 2a here, and they've got this 1 here, so somehow I've got to bring in, and I got a 2a in, so they're obviously trying to fit this into a space of just 1. Okay, so I guess now we can just take it to the power. So I've got this. I just got to take it to the power here. So root 3 minus root 2 to the 2n. Now if I got to do that for everything, but if I do it to 0, it doesn't change the 0. And if I do it to the 1, it doesn't change the 1. So that's fine. And then at this point, let's see here. Well, how can I proceed here now? Let's see here. I think okay, so at this point we're gonna have to do a little bit of fancy algebra. Nothing super fancy, but we're gonna have to add root 3 plus that root 2 to the 2n, to everything, to n I should say, not m, to n, to everything here. So if I add it to that, it just becomes root 3 plus root 2 to the 2n. If I add it to this guy, it becomes root 3 plus root 2 to the 2n plus that root 3 minus root 2 to the 2n. And then if I add it to this, it just becomes 1 plus that root 3 plus root 2 to the 2n. Like that. Okay, so where do I go from here? Well, this part here, I don't think there's much I can do to change that. This part is just going to be the same, root 3 plus root 2 to the 2n. But this one here, this guy is this, so that's just 2an, so that's at least something good. And then this is just your root 3 plus root 2 to the 2n, and then plus that 1. Okay, so I think, let me just go back here. I think we're getting very close to this guy here, because we got this part already. See, this part is already 2an is greater than root 3 plus root 2 to the 2n. And then, so that part of it is already done, this part. Now to get, let me think about this now. How do I get, oh, okay, to get this part, we just have to fiddle around with this. If we put this 1 over on the other side, it becomes 2an minus 1, and then we'll just leave this, which is just that. Okay, so I have a little bit of fiddling around to get this final result, and this is pretty much what they wanted us to prove. Let dn be the ones units digit of the number root 3 plus root 2 to the 2n when it is written in decimal form. Determine with justification the value of d1, d2 all the way to 1867. 1867. Is that the year Canada became independent? Canada independence? I think so. I wonder if they chose that number for a reason. Okay, so how do we do this question? I think this will involve some extrapolation because I think we're going to have to look for a pattern here because otherwise I don't see how. So we're going to make a little list here. We have n, and then we have d to the n, and actually in particular, what is d to the n? It's the units digit. Units digit of root 3 plus root 2 all to the 2n. Okay, and then let's see if we get a pattern. Now, you guys can do this. You just take a calculator, put in a value of n, like for example, when n is 1, and then just figure out what is the units digit. And I did that, so this is a 9. When n is 2, it becomes a 7. When n is 3, like for example, when n is 1, right, it would be root 3 plus root 2 to the 2 times 1. And this is 3.14 approximately squared, and that would be 9 something. So this is the units digit, and that's why I put a 9 there, just in case you're wondering how did I figure that out. Okay, so when it's 2, it's 7, 9. When it's 3, when n is 4, it's 1. When 5, it's 9. When 6, it's 7. When it's 7, it's 9. And when it's 8, it's 1. So what you'll see is that there's a pattern here, 9791. And then we're going all the way down to 1867, right? So it'd be helpful if we knew if 1867 is divisible by 4, and it's not. 1864 is divisible by 4. So that means that until we get to 1864, we're going to have patterns of 4, and then we're going to have to count 1865, 1866. 1865, since the pattern ends 9791, the pattern would start up again 979. Yeah, the pattern starting up again, right? Okay, so it shouldn't be that hard. We're going to have 466s of these guys. So 466s of a 9 plus a 7 plus a 9 plus a 1. And then we're going to have these 3 guys left over, so the 9 plus a 7 plus a 9. And that all total is 12141. And that is the answer.